So for this next problem, this is the answer that little Johnny came up with. Little Johnny thinks he factored his problem all the way correctly and he thinks he's done. Doesn't matter what the original problem is. We need to look at this to see, did he actually factor it all the way? So you remember at the very end of all the problems, we would always ask, because you think you're done, that you needed to double check. That's what this problem is going to be. I need you to double check a few things. So first, double check the GCF. Is there a GCF in these two terms that could be divided out? There is. 2 and 6. What number do 2 and 6 have in common? I can divide both of those by 2. So this parenthesis right here, I'm going to divide both of those sides by 2. 2x divided by 2 gives me x. 6 divided by 2 is 3. So I just factored him out of GCF. These are connected by multiplication, so let's look at something else. Does he have a GCF that they have in common? 3 and 4, I can't divide 3 and 4 by the same thing. But x squared and x, they do have a GCF. They each have an x in common, so that had a GCF of an x. So if I divided both of these by x, 3x squared divided by x is a 3x. 4x divided by x is a positive 4. So little Johnny did not do the problem correctly. It is not fully factored. These are my two parentheses. So I've got my x plus 3 parenthesis, and I have my 3x plus 4 parenthesis. These are the two GCFs that little Johnny didn't take out like he should have. He didn't factor them out. So at first I factored out a 2, and then I factored out an x. So little Johnny should have factored out a 2x altogether in the end. This is why we always double check GCFs. The next thing that you need to check is the difference of squares. Did little Johnny mess up and not do a difference of squares problem? Well, he's not subtraction, so that's not a difference of squares. He's also not a subtraction, so he's not a difference of squares. So this is the answer little Johnny should have had. Little Johnny did not get the right answer. We found more GCFs that little Johnny should have factored out. So we're being asked to factor. The first thing that we always look for is a GCF. Is there a GCF in here? They all share an x except for him, so no variables in common. They all share coefficients except for these two, so no coefficient in common. So my GCF is just a 1, which means I can't divide anybody. So the next thing I need to do is factor it. There are 4 terms. If I recognize 4 terms, that means first I need to make sure it's in standard form and then put it in the area model. It goes x to the third, x squared, x to the first, no x. So it is in standard form. So I am just going to area model it. So x to the third. Is there a GCF in common up here? They both share an x squared, but they do not share a common coefficient. So my number is just x squared. X squared times x is an x to the third. X squared times 4 gives me a 4x squared. 4 times a negative 1 gives me a negative 4. X times negative 1 gives me a negative 1x. So my answer is x squared minus 1 and x plus 4. So I just factored. So I actually think I'm done. So my job is to double check. The very first thing you always need to double check is the GCF. Can I divide both of these by the same number or variable? No, so he's fine. Can I divide both of these by the same number or variable? No, so he's fine. So there are no GCFs. So the second thing that I need to look for a difference of squares. Did I miss one? He is a difference. Okay, are they squares? Can he be divided by 2? Yes. Can you take the square root of 1? I can. So the square root of x squared is x. The square root of 1 is 1. And it was subtraction. So this parenthesis right here needs to be rewritten as a difference of 2 squares. Remember, difference had a minus and a plus. The front's solved was x, so here's my x's. The back square root was 1, so here's my 1's. So this got factored more to these two. Is this a difference of 2 squares? Well, he's not subtraction, so no. So he was fine exactly the way he is. We don't need to do him anymore. This is our final answer, and we are done. So we're being asked to factor. The very first thing you always do is you need to identify a GCF. Can I divide all of these by the same factor? Yes, every single one of these can be divided by a 2. Can I divide all of these by the same variable? Yes, every single one of those can be divided by an x. So my GCF is 2x. So I'm going to divide everybody by a 2x and see what I have left. 2x to the third divided by 2x is an x squared. 6x squared divided by 2x is a positive 3x. Negative 2x divided by 2x is a minus 1. So this is now what I need to double check and see if I can factor. There were 3 terms. because there's 3 terms, you need to ask yourself if A was 1 or if A is not 1. That's if you want to be able to use the trick. I'm going to pretend that we don't know how to use the trick. So if I don't remember how to use the trick, I am just going to do the area model, which means I need to do A, I need to do B, and I need to do C. So I need to figure out what is A times C that adds up to B. My job is to split this middle term into 4 so I could use the area model. So A times C is a -1, B was a 3. Are there any numbers that multiply to give me -1 but add to give me 3? Well, 1 times -1 would multiply to give me -1, but when I add those I get 0. There's no other way to multiply together to get -1. So this is the only list, which means I couldn't factor it at all, which meant I was completely done. So I didn't need to do an area model or anything. My answer is 2x times a x squared plus 3x minus 1. This was my final answer in fully factored form. So we're being asked to factor. Very first thing you always need to check for is a GCF. Can I divide 5 and -45 by a same number? I can. I can divide everybody by 5. X to the 4th and x squared. How many x's do both of them have in common? They have x squared in common. So my GCF is 5x squared. So I need to divide everybody by a 5x squared. 5x to the 4th divided by 5x squared gives me x squared. -45 x squared divided by 5x squared gives me a -9. So I just factored out my GCF. Now I need to look at my parenthesis. There are 2 terms. We only know one way to do 2 terms, and that is to do the difference of squares. So can I take the square root of the front? Square root of x squared is x. Can I take the square root of the back? Square root of 9 is 3. Is he a subtraction problem? He is. So I can do the difference of squares on him. Don't forget your GCF. Now here are my 2 parentheses for difference of squares. One has to be plus, one has to be minus. My x squareds gave me my x, so my x's are in the front. My 9s gave me my 3, so my 3s are in the back. Now I think I'm done. So I need to double check. Did I miss a GCF? X and 3. I can't divide x and 3 by the same number or variable, so no GCF there. X and -3. Can I divide those by the same number or variable? Nope, so no GCF there. So I have no hidden GCFs. Okay, do I have any additional hidden difference of squares that I need to do again? He's not a difference, so no, he's safe. He is a difference. Can I square root 3? I cannot. So I just double checked everything that needed to be double checked. He is my final answer, and I am done.